sorry, ice at 1 kg and minus 10 degrees centigrade. The absolute unit for the temperature is Kelvin. So therefore 10 degrees centigrade minus 10 degrees centigrade is equivalent to 263 Kelvin. Okay, you can see initially, you can see here the minus 263 at state 1 initial point in all the diagrams. State 1 is corresponding to 263 Kelvin or minus 10 degrees centigrade, right now. So here the generation of the steam from the ice can be taking place in 3 ways. First one will be, first we need to convert, or let us say we need to change the temperature minus 10 degrees to 0 degrees centigrade. First minus the heating of water, or I can say first initial case, what will happen if you heat, the ice will not melt, but it will decrease its temperature, but it still remain in ice at 0 degrees centigrade. Means first minus 10 degrees centigrade to 0 degrees centigrade. If you heat, what will happen? The temperature will decrease, but it will be remains ice at 0 degrees centigrade. Okay, so now you can see this is the state 2. State 1 is ice at minus 10 degrees centigrade. State 2 is also ice at 0 degrees centigrade. This is called what? Sensible heat or latent heat? Sensible heat or latent heat? Please tell me. There is no change of the phase. Only temperature is going to decrease. Not decrease, increase. Minus 10 to 0. So same phase I can call it as sensible heat. Sensible heating of ice. During this process, the temperature will change from minus 10 degrees centigrade to 0 degrees centigrade by keeping the same phase, that is ice phase. You can see state 2 in this diagram. State 2 will shows that it is also ice at 0 degrees centigrade. The corresponding absolute scale is 273 Kelvin. Observe the graph similarly. Clear now? State 1 is what? State 2 is what? Tell me, anyone. Please explain. Very, very important question. Formation of the steam or generation of the steam. State 1 corresponding to ice at minus 10 degrees centigrade. State 2 is also ice, but the temperature is 0 degrees centigrade. Okay. Now, next what we are doing, now at state 2, we are having ice at 0 degrees centigrade. Now, further heating of ice, what will happen? It starts melting. Yes or no? If you heat the ice, what will happen? It starts melting. Okay. So now 0 degrees centigrade to, let us say it is keep on increasing. Then what will happen? It will be converted into water. Okay, first let us say 0 degrees centigrade to 4 degrees centigrade. Now if you see temperature versus volume diagram, so at state 3 is corresponding to 0 degrees centigrade, and state 3 dash, what is the centigrade? Tell me. This is Kelvin. 277 Kelvin is equivalent to 4 degrees centigrade, right? So means 0 to 4 degrees centigrade. If you heat the ice at 0 degrees centigrade, 0 to 4 degrees centigrade, what happens to the volume? If you see, the volume is decreasing slightly, 3 to 3 dash. Generally, if you melt the ice, the volume will increase. If you melt the ice, the volume will increase. Okay. So, but 0 to 4 degrees centigrade, instead of increasing its volume, what will happen? The volume is getting decreased slightly. Okay. Then further, what will happen? It is increased. So now you can see. So again 3 to 4 dash. 3 to 4 dash, the volume is also increasing. At state 3, it is, that's what melting. 2 to 3 is the latent heat. Okay. So again I am repeating. State 1 minus 10 degrees centigrade ice. Okay. So we are heating, therefore it is at 2 also it is ice, but the temperature is 0 degrees centigrade. Okay. So state 1 is solid, state 2 is also solid. Now at state 2, further adding of heat, what will happen is this ice starts melting. Okay. At 3, we are getting water. It's liquid phase. Clear now? At 3, this is water at 0 degrees centigrade. At 2, ice at 0 degrees centigrade. 2 to 3, temperature remains the same, but phase is changing. This is called latent heat of fusion. The heat required to convert the ice to water is called latent heat. by maintaining the temperature constant. All of you, please tell me, is it clear?
Yes, sir.
So 122 is the sensible heat, 223 is the latent heat. Simply, if you want to say 122 is the sensible heat and 223 is the latent heat. I am telling difference once again. Sensible heat is same phase, different temperature. Latent heat means different phases at same temperature. Clear for all of you now? If phase change occurs, that is the latent heat.
Yes, sir.
And from 3 to 4, if you see, yeah, that's what. From 3 to 4, from 0 degrees to 4 degrees centigrade, there will be slight decrease in the volume. Further, again, it will be increased. Okay. So the heat required to change from liquid state to, now what will happen after 3, if you supply the heat, the water starts boiling. Okay. So the water starts boiling, right? So at state 4, it is the combination of liquid plus vapor. This is liquid, solid, solid, right? So 3 to 4 boiling is taking place. Okay, the heat required to change from liquid state to vaporized state or evaporation, so or boiling, that is called sensible heating. Okay, sensible heating. Here it will be hot water, partial vapors will be there. Okay, and heat required to complete transformation of this liquid into vapor. Okay, heat required to complete. Now 4 to 5, if you see, the temperature constant but phase is changing. This is liquid plus vapor and this is vapor, pure vapor, and this is called latent heat of vaporization. This 2 to 3 is called latent heat of fusion. This is called latent heat of vaporization, the 4 to 5. So the temperature remains the same but phase is changing. Okay, again, then at 5, if you add further heat, so what will happen? It will become superheated. This is superheating of steam, 5 to 6 at constant pressure. If you see, this line is the constant pressure line. So at constant pressure heating, this is the superheating. Okay, so this is the formation of the state heat steam. So 1 to 2 solid state, 2 to 3 is the melting, 3 to 4 liquid state, 4 to 5 evaporation or vaporization, 5 to 6 it is the superheating. Now in the same way you can observe this PV diagram, right? Now, so in PV diagram, this is the constant pressure line, horizontal line. Okay, as you know, this is saturated liquid line, this is the saturated vapor line. These liquid line and vapor line are meeting at a point. We can call that as a critical point. This entire process is taking place at constant pressure. This starting from state 1 to ending with state 6, this total process is taking place at constant pressure. Okay, you can see all the points are marked over a straight line. It indicates that it is all process are carried out by maintaining the pressure constant. 1 to 2, changing of temperature of ice. 2 to 3 is the melting. Okay, 2 to 3 is the melting. Next, 3 to 4. What is 3 to 4? Tell me.
Volume is decreasing
Boiling
at a point.
Slightly, we can't identify. Very low. You can see instead of vertical line, it will be just slightly.
It is negligible, sir.
Negligible. Again, one will be studied in physics of intermediate or 10th. So why the water animals are living below the ice? You might have observed, right?
Yes, sir. Below the ice, water is
Solid ice.
warmer.
That's what. Why? That is the reason. Okay. And this entire process is taking place at constant pressure. This is the superheated one. This is saturated vapor. This is saturated liquid. Clear this one?
Yes, sir.
And if you see from bottom to top, between the distance between the horizontal distance between saturated liquid line and saturated vapor line is keep on decreasing. If you move upward direction, this particular distance is keep on decreasing, and there is no distance at the critical point. Critical point represents the highest temperature and pressure. Above this point, the liquid cannot exist. Above this point, the liquid cannot exist. Okay. The temperature and pressure at the critical point are called critical temperature and critical pressure. Okay. For that water, the critical pressure is 220.9 bar. The critical pressure of the water is 220.9 bar, and critical temperature is 374.14 degrees centigrade. Critical temperature and critical pressure at this point. Okay. Next, we will see triple point of water. Triple point of water. Let us consider pressure versus temperature diagram. Pressure versus temperature diagram. We can see here, this line is the fusion line, right? So from here to here, melting is taking place. This line is the evaporation line. From here to here, evaporation is taking place, and this is the sublimation line. Okay. So what is sublimation? Can anyone tell me? Sublimation and sublimation. Diploma people, what is sublimation?
It was there in intermediate, sir, but I forgot.
Yeah, that's what. Sublimation is the conversion of solid to vapor, directly ice to steam.
Yes.
Ice to steam, right now? Right, that is the sublimation line, and the reverse is sublimation, steam to ice or vapor to solid. Okay. Now you can see the sublimation line. This is sublimation line, this is evaporation line, and this is the fusion line. All these three lines are meeting at a point. That point is called triple point. Triple point is a point where the fusion line, evaporation line, and sublimation line are meeting. That point is called triple point. I can define. Now you can see along this melting line, solid phase and liquid phases are in equilibrium. Okay. So along this sublimation line, solid phase and vapor phases are in equilibrium, and along this evaporation line, liquid and vapor phases are in equilibrium. Okay, right. So these 3 points are meeting at a point, and this point is called triple point. We can define this triple point as the point at which the 3 phases of water. The 3 phases means it is a solid, liquid, and gas. So these 3 phases are equilibrium. That point is called triple point of water. Okay, and the triple point of water value is equals to T triple point. Triple point temperature is 0.01 degree centigrade, and pressure at triple point is equals to 0.611 kilopascal. Okay, the sublimation, the fusion, the evaporation lines are meeting at a point. That point is called triple point, or it can also be defined as 3 phases, that is solid, liquid, and vapor phases coexist in the equilibrium. That point is called triple point. Okay, and sublimation refers to the heating process, right? So if you see from 1 to T, it is the heating process. Directly the solid water or ice gets directly transformed to saturated vapor phase without melting into water. Okay, that process is called sublimation, and the reverse process is called sublimation. Okay, so this is about the triple point of water. Along the, again I am repeating, along the fusion line, liquid and solid are in equilibrium. Along the sublimation line, solid and liquid vapor phases are in equilibrium. Along the evaporation line, liquid and vapor phases are in equilibrium. Okay, so that the 3 lines are meeting at a point, that is sublimation, evaporation, and fusion line. That point is called triple point of water. The corresponding values are 0.01 degree centigrade, 0.611 kilopascal. Okay, and we already studied about dryness fraction, right? Yes or no? What is dryness fraction? Okay, I will repeat again. First, tell me what is vaporization?
Conversion.
What is vaporization?
To
Conversion
vapors.
of vapor means
Liquid
phase
to
change is there.
vapors.
Yes, all right. Yeah, change of phase from liquid to vapor. Okay, so that is called the process that involves the change of phase from liquid to vapor phase. That is called vaporization. Right now, then what is evaporation? Then what is evaporation? It is
Same.
the process of generation of vapor, right? So this evaporation can take place. Let us consider a water. The evaporation can take place from the free surface of the liquid. The evaporation can take place from the free surface of the liquid, or it may start from liquid. Okay, na? It may start from liquid. Means if you heat the water, what happens to its kinetic energy? So its temperature increases. When temperature increases, the kinetic energy of the particles also increases. Therefore, it start moving from the free surface, right now, boundary of the water, right, in the form of vapors. That process is called evaporation, right now. So when heat added, what will happen? It starts boiling and vapors get generated from both free surface as well as inside the liquid. Okay, and this boiling refers to the formation of the vapors, okay, which takes place from the whole mass of the fluid. Okay, so when all the liquid present inside this one will get converted into vapor, so then we can say that vaporization is completed. Okay, all right. Now what is saturated stream? What is saturated stream?
Liquid phase.
Liquid phase? No, I'm calling it as steam, saturated steam.
No water molecules are there.
Saturated steam is
Complete steam.
complete steam is that is superheated steam, no?
I mean,
Whether the steam is saturated steam or superheated steam, it is discriminated by knowing its dryness fraction. Agree? Yes or no? If x is less than 1, it is. If x less than 1, what is the name of that steam?
Super cold.
X less than 1, x equals to 1, x greater than 1. Okay, so x equal to 1, it is the dry and saturated steam. It is, yeah, this is superheated steam, this is wet steam. Okay, so the x less than 1, this is the wet steam. When x equals to 1, it is the dry and saturated steam. When x greater than 1, this is the superheated steam. Okay, right. So how can we say that the steam is superheated? So when the molecules escaping, let us consider the water. Okay, so if you heat the water, as I told, temperature increases, its kinetic energy increases. Therefore, the water particle molecules starts evaporating from free surface as well as within the liquid. Okay, so the steam can be called it as saturated when the molecules escaping from the liquid becomes equal to molecules return to it. Right, some molecules will be escaping due to increased kinetic energy. Some molecules are coming back due to decreased kinetic energy, right now. So because of the condensation and other reason. Okay, so therefore when the molecules escaping from the liquid become equal to the molecules return to it, then I can call that particular steam as saturated steam. Okay, and the liquid at its boiling point. Okay, this is about saturated steam. The saturation steam may be either dry or wet. When the saturated steam contains vapors, okay, so when the saturated stream contains vapors, then we can call it as wet saturated stream. Okay, and usually, as I told, it is denoted with dryness fraction. it is denoted symbol X, we can define the Reynolds fraction as mg by mixture. Mixture is nothing but fluid plus gas. Okay, the ratio of mass of dry saturated vapor. The ratio of mass of dry saturated vapor to the mass of the mixture. Mixture means vapor plus fluid. And the reverse of this dryness fraction is called wetness fraction, that is denoted by some, not reverse, the 1 minus x. Okay, y is equals to mass of the fluid by mass of the mixture. Mass of the fluid by mass of the mixture, that is called wetness fraction. Okay, so if we express this dryness fraction in terms of percentage, if we express this dryness fraction in terms of percentage, then I can call it as quality of the steam. Quality of the steam is nothing but expressing the dryness fraction in terms of percentage. So this is the wetness fraction. If we express this wetness fraction in terms of percentage, okay, then we can call it as priming. We can call it as priming. If you see, if you subtract x from 1, so what you will get? You will get y. So 1 minus x is equals to y, or I can call it as x plus y is equals to y. Okay, this is the sum of dryness fraction plus wetness fraction is equals to the 1. Okay, and if you heat the saturated steam, what will happen? It will be converted into the superheated steam. Okay, so therefore we can define the steam, so superheated steam. Okay, so steam becomes superheated at a given pressure if its temperature is higher than the saturation temperature. As you remember, the entire formation of the steam, if you see from starting from ice to steam, it is taking place at constant pressure. Pressure is equals constant, right? So at this, on this line somewhere I am getting steam. I am further heating this steam. What I am getting? I am getting superheated steam. This is superheated steam. This is saturated steam, dry and saturated steam. If you heat the steam, it will become superheated. Okay, right? So that let us assume the temperature corresponding to this saturation steam is Ts. The temperature corresponding to superheated steam is T super. Okay, the difference of temperature between superheated steam and saturated steam is called degree of superheat. Degree of superheat. Important for problem. T sup minus T short. You can say T sat also. Superheated temperature minus saturation temperature is called difference of superheated temperature and saturation temperature is also called as a degree of superheat. Okay. So this is about the steam tables. We already discussed that. Let us take one example. Determine the saturation pressure, specific volume, internal energy and enthalpy for saturated water vapor at 45 degrees centigrade and 50 degrees centigrade. Sorry. So you want pressure, volume, internal energy, enthalpy for water vapor at 45 degrees centigrade and 50 degrees centigrade at different temperatures you want. At different temperatures, right? Now, so which tables you need to refer? You need to refer water and saturated steam tables. That may be table 1 or table 2. Again, it depends upon temperature. The value is given as temperature, 45 degrees and 50 degrees centigrade. Therefore, the first column of the table should be temperature. Right. I'm going to the first table. Right. What is the temperature given? 45 degrees and 50 degrees. Let me open. Yeah, 45 degrees and 50 degrees. Where is 45 degrees? Here. This is 45 degrees. At this temperature, now you need to observe this complete horizontal line. This complete line you need to see. Is this highlighter is visible to you? Yellow one, yellow colored one?
Yes, sir.
Right. Now, at 45 degrees, what are the properties required? Tell me. Pressure. Now, tell me what is the saturation pressure corresponding to 45 degrees centigrade? 0.09582 bars, because the units are bar for the second column, absolute pressure. Okay, that is the pressure. Then what is the second one? Specific volume. What is specific volume? At 45 degrees centigrade, it is fluid or a gas? Tell me. At 45 degrees centigrade, it is fluid or gas?
Fluid.
Fluid. Therefore, you should consider VF. Agree? So at 45 degrees centigrade, specific volume is equals to 0.001010 meter cube per kg. Okay, you can find the units in the first row. You can see specific volume is in meter cube per kg and pressure is in bar. Okay, so at 45 we are seeing all those things. Next, third one, enthalpy. Sorry, specific volume is our internal energy. So internal energy is there? No, internal energy we need to calculate by using the formula. How to calculate internal energy? How to calculate internal energy?
M into dV.
Yeah, M into CV
MdV
into dt. Right?
CV
For
into
specific mass, it is CV into dt. dt is the difference of temperature. Okay, right. Now enthalpy. Enthalpy directly we can get it. So it is again fluid. We need to consider HF. HF value at 45 degrees centigrade. Then that's it. At 45 degrees as well as 50 degrees we need to consider. So at 50 degrees also we require all these values. Depends upon the condition given. 45 degrees it is like a fluid, even 50 degrees also it is a water. Now second one, determine the pressure, volume, internal energy and enthalpy for saturated vapor at 47 degrees centigrade. Right. Now if you see in this table, 47 is okay available, right? Sometimes we should go for the interpolation also. Okay, so I'll tell you when it is required to go for interpolation. Right. So interpolation. Maybe how you come across in C computers. Okay. Let us say I have data at 40 degrees centigrade. I have data at 45 degrees centigrade. I want to calculate, let us say I'm calculating specific volume of the fluid. I have at VF, I have some value, right? At 40 degrees, I have something. At 45 degrees also, I have something. I want to calculate at 42 degrees centigrade, right? So what you need to do? First, you need to calculate at for 1 degree, what is the value? 45 degree minus 40 degree by 5 degrees centigrade. Means at 1 degree, for 1 degree centigrade, we will get VF. Okay, so therefore now I can write VF at 42 is equals to, directly I have VF at 40 plus 2 into VF at 1 degree centigrade. This is the interpolation method for any property, not only volume, for pressure, enthalpy, entropy, specific volume, anything you can use, right? First, you need to calculate for 1 degree centigrade, right? Already I have the value for 40 degrees centigrade. I want for 42, 40 plus 2 into 1 degree. You will get the required one. Clear now? Please tell me.
Sir, how 1 degree? How to get VF at 1 degree?
VF at 43.
1 degree, sir.
Can you 1 degree? How to get 1 degree, right? 45 minus 40. How much? What is the difference? 45 minus 40 is the 5 degree, means you will get cumulative for 5 degree. If I divide with 5, number 5, then I will get for 1 degree. Getting or not?
Yes, sir.
45 degree minus 40 degree, I will get cumulatively for 5 degrees. I want for one particular degree, I should divide with 5. Therefore, I will get for 1 degree. Then if I multiply with 2, I will get 2 degree. If I multiply by 5 degrees, I will get again. That is the way to do the interpolation. Okay, so this is also similar one. Now, here he mentioned interpolation. What I explained just now. For any property, we can use this one. For any property, we can use this one. You can see 45, 50 is there. Okay. For the same only we will do. Let us say 45 is there, 50 is there. So at any point, if you want to right. Now we will do for this one at 45 degrees. Now I want saturation pressure at 47 degrees centigrade, right? So at 45 degrees, what is the saturation pressure? 9.5953. At 50 degrees centigrade, the saturation pressure is equals to 12.352 bar. Okay, right, for 1 degree. So that is equals to T50 minus T45 divided by 5. Getting or not? T50 minus T45 by 5. So T50 is 12.352. Can anyone open the calculator? 9.5953 divided by 5. Please tell me how much this value? How much this value? 12.352. Make it fast. 352 minus 9 point. How much?
Sir, 0.55.
0.55.
0.55.
0.5513. I got same. Now I want P saturation pressure at any 47. Let us say 47 is equals to saturation pressure at 45 plus T into 2 into, because 45 plus 2, 0.5513. 0.5513 into 2, it will be 1.10268 plus 9.5953. It will be 10 point, check it, 10.69798 I got kilopascal. This is the saturation pressure at 47 degrees centigrade. If you want to calculate at 49 degrees centigrade, what you will do, tell me? For 1 degree, you need to calculate the respective property for 1 degree centigrade. What is that value? And how many degrees you need to add, that number you should multiply. Now for 49, I should add 45 plus 4. Therefore, this into 4 plus 45. If I want 48, this into 3 plus 45. Clear this one? Interpolation method to find the properties. Students, tell me, is it clear or not?
Sir, once again explain.
Once again, okay. See here, you have the data corresponding to 45 degrees centigrade. you have pressure, specific volume, internal energy, enthalpy. Okay, and the same properties for 50 degrees also, right? Suppose in the problem you need to calculate at 47 degrees centigrade. That is, you require data of pressure, volume, internal energy, enthalpy at 47 degrees centigrade, right? So you don't have directly at 47 degrees centigrade from table. Let us assume out at that time how to find for 47. Okay, for 45 degrees, the data for 50 degrees centigrade. If you subtract 50 minus 45, if you subtract 50 minus 45, you will get cumulatively for 5 degrees centigrade. But I want for one particular degree, therefore I am dividing with 5. Because the difference of temperature is 5, that's why I'm dividing with 5. Suppose here I have 45, here I have 52. What is the difference? 7. At that time I should divide with 7. It depends upon the temperature difference, or simply you can remember 50 minus 45. This 50 minus 45. So therefore you will get the corresponding pressure for 1 degree centigrade, right? But I want for 47 degrees centigrade, the saturation pressure. For that, I have directly 45 degrees centigrade. What is the saturation pressure? And 2 more degrees I need to add. So that is 2 into 1 degree saturation pressure is this much. Therefore, you will get saturation pressure corresponding to 47. Similarly, we can go for volume, internal energy, enthalpy also. Now, is it clear?
Yes, sir.
Right. So with this, we will stop today, and next class we will solve problems.